to another tutorial by harlepenguin.com. My name is Norm and I will be your host today. For today's tutorial, we are going to continue our study of the open shading language. We are going to create this interesting volumetric shape using just a sphere and some simple OSL code. So let's get started. First, let's set up our screen. And to do this, I am going to delete the default cube. I am going to add a UV sphere, and I will scale this so that it fills our screen. Maybe move the camera down a little bit. Set smooth shading. All right, switching over to Cycles Render, and make sure to check the Open Shading Language box. And I am using version 2.79a of Blender, which is very important because as I've mentioned in a previous tutorial, if you use 2.79, this code will not work due to a bug in the volume shader. We are going to split the screen and split it again. And I will make this top one the node editor. And I will make this bottom one the text editor. So we are going to create a new text document, and I am going to call this inside.osl. And for the main piece of this, we will say volume inside. We are going to have a few parameters. First, we will have radius with a default value of 1. And I will explain these in a minute. Float seed equals 0. Float scale equals 1. And then output, missed one. Color, input color with a default value of white. Output, closure, color, BSDF equals 0. And brackets. All right, so now what are we going to do for this? Next, we are going to create a variable called current noise, and we are going to use the OpenShader noise function, and specifically the Perlin type noise. You can look in the shader specification for different types of noise. Perlin just means it generates a deterministic value between -1 and 1. For inputs, we are going to use the current point, and then we will use our seed parameter. And the reason that we are using the seed parameter is so that over time, we can keyframe that seed and change the shape of the internal based on this seed parameter. Next, we are going to calculate a variable called current radius, and we are going to make this equal to the length of P, which is just the distance from the origin to this particular point. We are going to add the current noise and multiply it times our scale parameter. And this just means that whatever that length is, we will add a number between -1 and 1, and then to change how much we want it to impact the length, we can change our scale parameter. Now, the way that we want this to work is we want to look at this current radius, and if the current point that we are looking at, which is P, is within the bounds of this current radius, then we want to show that particle. However, if it is outside the bounds, so beyond the radius, we do not want to show it. So for this, we will have an if statement. If the current radius is less than the radius we set here, then we're going to make this closure equal to the Henyey-Greenstein function times a scaling factor of 50, which just makes the function more dense, multiplied by our input color. For more information about the Henyey-Greenstein closure, take a look at our blog, where we will give a little bit more explanation and explain what different values do for this particular closure. Okay, and that's it. So let's go ahead and render this. Let me set up our nodes first. So for our material, we need a new material. Zoom in, get rid of the diffuse, and I will add a script node. We'll add our inside.osl, everything compiles correctly, connect that to the volume. And let's set our scaling factor to 2. And let's go ahead and look at this. So as you can see, we have an interesting shape that is generated by this. And if we change our seed, we can change what that shape looks like. Oops. We can also change what that shape looks like by our scaling factor. So make it outside. In fact, we can take it all the way up so it mostly fills in. We can take it down so it's very much in the center. And of course, we can change our input color. Now, one thing you'll notice based on the way that the Henyey-Greenstein works is the color, the visible color, because of how the light is scattered, tends to be the opposite of what you set as the input color. So if you want a green color, you set the input color as more of a purple, and you can see that some of it is reflecting purple, some of it is reflecting green. So what I did to make the animation, as you can see, this was all very fast to set up. What I did to make this animation is I actually keyframed the seed. So I add a keyframe for frame number 1, and then for frame number 250, I add another one, and we'll insert the keyframe. Then we can look at what does that look like. You can see that it just changes, and how much it changes depends on how much our seed changes. So maybe that might be too much. So let's set it for about 10. I want this. I forgot to mention the radius also controls how big this is. So we'll keep our radius of 1, and I want the scale I want to scale out just a little bit. Okay. That looks great. All right, so the last piece that I added to this is I wanted a little bit of camera movement. So I wanted to rotate the camera around. So for this, what I'm going to do is I'm going to use a script, and you can take a look at one of our previous tutorials that describes how to use Python, and particularly the NumPy library in Python, to set up a camera rotation. So to do that, we are going to open a new text block. And I'm going to import our script, rotate.py. Again, this code is available on harlepenguin.com. And I'm going to change, so we have our camera, we have our sphere, and I'm going to run the script. And then hopefully, as you can see, it rotates around. We will select the camera, select the object, Control T, track to constraint. And I want the radius to be a little bit larger. So that's good, just much too close. So let's go 10 and we'll run the script again. And that's much better. Maybe about 12. Looks good. Okay. And that's all it takes. As you can see, very interesting shape. We will put a little bit of additional detail as well as the code for this shader on harlepenguin.com. Please let us know if you have any questions or comments. Thanks for watching.